In this review session, we're going to talk about two of the several methods for factoring. And the two factoring methods that we are going to talk about in this particular lesson, we are going to talk about greatest common factor. We're going to talk about difference of squares. So when you have a greatest common factor, it does not matter how many terms that you have, but a greatest common factor is the largest number that each coefficient has in common as a factor, such as with 24 and 54 in example number 1, the largest number that you can divide both 24 and 54 by is 6. As far as the variables are concerned, if your terms have the same variables, such as in number 1, I have y to the fourth in the first term and y to the third in the second term, you always take the smallest power. So we're going to go with y to the third. 6y to the third is the greatest common factor. Now, in order to factor it, basically what we're going to do is undistribute this particular problem. So I start with two terms. What I put in my group, I put two reduced terms back. Well, how do I reduce those terms? I reduce those terms by the greatest common factor. So my mindset, my thought process, once I get my GCF, 24 divided by 6 is 4. That reduces 24 by 6. And then I subtract the exponents, y to the fourth and y to the third. When I subtract 4 minus 3, I get y to the first. I move on to the second term and I do the same thing. Negative 54 divided by 6 is negative 9. And when I look at the variables, 3 minus 3 is 0, so the y cancels out because y to the 0 power would be a 1, and 1 times 9 would stay 9. So before I make sure that this, or before I state that this is my answer, I make sure that what is in the group have nothing in common. The two terms in the group can have nothing in common. So when I look at what's in the group, 4 and 9 have nothing in common but 1. The first term has a y in it, but the second term in the group does not. So therefore, I have factored it as far as I can factor using the greatest common factor method. Now, when I look at example number 2, the first thing I consider is 51 and 17. The biggest number that I can divide 51 and 17 by is 17. The next thing I look at are the variables. If you notice, the first term has a to the 8th and the second term has a to the 3rd. You always take the smallest exponent. Then my first term has a b to the 4th. My second term has b to the 5th. You take the smallest exponent. If you had hypothetically a term that had a b, but the other term did not have a b, then you don't have a factor of a b in common, because in order for you to have a common factor b, both terms have to have at least a b in them. So now I'm going to reduce the original terms by the greatest common factor. So I'm going to divide the numbers and I'm going to subtract the exponents of the like variables. So 51 divided by 17 is 3. 8 minus 3 gives me a to the 5th. When I look at the exponents on b, 4 minus 4 is 0, so that cancels out. When I go to the second term, 17 divided by 17 is 1. A to the 3rd, when I subtract 3 minus 3, I get 0, so I don't have any a's for the second term. And then b to the 5th and b to the 4th, when I subtract 5 minus 4, I end up with b to the 1st. Now, before I state that this is my answer, I look at the two terms in the group. Do these two terms have anything in common other than 1? They do not. So therefore, that is my answer using the greatest common factor method. Now, the next thing we're going to do in this particular review session is we're going to talk about perfect squares. and we're going to talk about the difference of square factoring using perfect squares. So some perfect square numbers: 1, 4. 1 is 1 times 1, 4 is 2 times 2. Then we have 9, which is 3 times 3. That's what makes it a square, is because you take one number and you multiply it by itself. So 16 would be the same as 4 squared. 25 is 5 squared, so on and so forth. I'm going to go out to 10 squared. These numbers should look familiar with you or to you. These are not the only perfect square numbers, but that's just from 1 squared all the way up to 10 squared. So the rule for factoring a difference of squares, it has to be x squared minus y squared. And if it is x squared minus y squared, then the factors are conjugates, x plus y and x minus y. Those are called conjugates with respect to each other because they have the same terms except they differ in signs. One has a plus in the group and the other one has a minus. So when I look at example 3, I notice that 36 and 25, the numerical aspect of it, both of those numbers are perfect squares. They're in my list. And when I look at my exponents always have to be even. You have to be able to divide your exponent in half. So it's not always going to be a w squared like you'll see in example 4 in just a moment. So this is a difference of squares. It's one squared term minus a second squared term. So you will always get two parentheses. In the first parentheses, I'm going to break up the 36 to 6 and 6. 6 times 6 is 36. And I'm going to break that w squared in half. 2 divided by 2 is 1. So that's why both parentheses gets a 6w. If I multiply that back together, it goes right back to 36w squared. Now, I'm going to put 1 plus and 1 minus because since I identified this as a difference of squares, my groups need different signs. The last thing I'll do is I'll break up that 25. 25 is in my group. That is the same thing as 5 squared, so I'm going to put a 5 as the last term in both groups. Now, before I state that this is my answer, I make sure that I did not accidentally miss a greatest common factor opportunity. If you notice in the first group, 6w plus 5 have nothing in common but 1, and 6w minus 5, the same thing. So those are the factors of that difference of squares polynomial. Now, number 4 looks a little bit different simply because the perfect square numbers are in fraction form. 1 over 144. 1 is a perfect square, 44 is a perfect square, which is 12 times 12. And then if you notice, all of my exponents are even, so I can divide them easily by 2. So what I'm going to do is I'm going to split up that 1 over 144 to 1 over 12, because 1 over 12 times itself is 1 over 144. I get 1 plus, 1 minus, and then for the second part, the r to the 6th, the second term, the r to the 6th, x to the 4th, I'm simply going to divide those exponents in half. So 6 divided by 2 is 3, and 4 divided by 2 is 2. So I'm going to give each group an r to the 3rd s squared. If I were to multiply those back together, it goes back to being r to the 6th and x s squared. Now, before I state that this is my answer, I make sure that the two terms in each group, these two terms and these two terms, have nothing in common with each other, and they do not. So this would be my final factors. Now, number 5 is a trick question, because if you look at the numbers 16 and 1, they were in our perfect squares list. If you look at the exponent is even, it's 4, and you can divide that evenly by 2. But what's wrong with this problem is it's not a difference of squares. That is not a subtraction sign. If that were a subtraction sign, then we would be able to factor it. But since it is a sum of squares, this is considered a prime problem because number one, we do not have a greatest common factor that we could factor out. And number two, this is a sum of squares, and I do not know how to factor that as of yet. At some point in your math career, you will learn how to factor that, but right now, it is considered prime because you cannot factor it as a difference of squares. In the last example for this particular video, we are going to talk about example number 6. If you look at the numerical part, 9 and 100, they are both in our list. All of my variables have even exponents, and I am subtracting these two terms. So I need to break all of these perfect squares up. So my first perfect square breaks up into 3. 3 times 3 is 9. A squared b. If I divide both of those exponents in the first term by 2, that's what I get. 4 divided by 2 is 2. 2 divided by 2 is 1. I need 1 plus and 1 minus. If you put minus in your first parentheses and plus in your second, that is fine. It's the same thing. You need one of each. It does not really matter which parentheses you put the plus or the minus in. What matters is that you have one of each. Now, I'm going to take that last term, 10 or 100c squared, and break it down into 10 times 10. Divide the exponent by 2, so c squared. When you divide 2 by 2, you get 1. Now, if I were to multiply those back together, I go right back to 100c squared. The last thing I do before I state that this is my answer is I make sure that these two terms have nothing in common with respect to each other than 1, and that these two terms have nothing in common with respect to each other in that group other than 1. Since they do not have anything else in common, that would be my final answer. If you need any further assistance or you would like some extra practice or you have some questions, please feel free to contact me and let me know.